Okay, so welcome everyone. My name is Roger Arnold. I am the Community Engagement Librarian at the Norwich Public Library. It is my pleasure and my role this evening to just welcome you on behalf of the library. And thanks so much to the Conservation Commission, the Norwich Conservation Commission, particularly Sherry Asa, for her good work in their good work in coordinating this and bringing this to our attention. We're so happy to sponsor this or co-sponsor this. So I'll just briefly let you know that we're happy to take questions throughout the presentation. If you want to put them through the chat, that'll be great. I'll see them. About 18 slides in, we'll have a pause for some questions on what you had seen, but just know that more will be upcoming. And so we'll take questions that are relevant for that part of the presentation, but then Kevin will go right back in, and then we'll hear more. We'll go to 8 or around 8, but we're really excited to talk all things vernal pools. So I'm going to actually stop talking. Welcome. And we'll turn it over to Sherry Asa to introduce our speaker.
Thank you, Roger. We're really happy to be part of this tonight. The Norwich Conservation Commission had been planning to start organizing some presentations for the community again, and then COVID hit, so our plans were put on hold. And then Roger offered to host webinars like this for us using the library's Zoom platform. And I think this is a perfect partnership for us. We're really happy to be doing this, and we hope we can do more of them. And we're pleased tonight to have Kevin kick off this partnership for us by talking about vernal pools and the amphibians that depend on them for reproduction. So a little background on Kevin. He grew up on the Maine coast, and that's where his interest in nature was shaped, particularly the reptiles and amphibians and insects found in and around the vernal pool in his backyard. So he came to Vermont then to attend the University of Vermont, where he received a bachelor's degree in wildlife biology with a minor in forestry. And while in college, he also developed an interest in ornithology and spent his summers working as an intern for the Green Mountain Club and as a field technician with the Bobolink Odyssey in Shelburne, Vermont. Then after college, he began working at the Vermont Center for Eco-Studies here in Norwich, and his role was as an Eco-AmeriCorps member. And then he became a full-time VCE staff member when that AmeriCorps service ended. So Kevin splits his time now between 2 VCE projects, this vernal pool monitoring project that he's going to talk about tonight, but also the New England Grassland Ambassadors Program. And both those positions entail him coordinating, training, and assisting volunteers who help collect data, and also landowners who wish to become stewards of these unique and threatened ecosystems. He hopes to build on VCE's community of volunteers, and you'll hear about some of those opportunities tonight, and to continue to grow these projects to reach a wider audience and a larger area. So tonight, Kevin then is going to talk to you about the Vernal Pool Project, how you might get involved as a pool monitor and or support the amphibian migration, which you may not have even heard of before, by serving as a kind of crossing guard during nights when they're crossing potentially dangerous roads. And we in the Conservation Commission, along with Kevin, are also planning 1 or more guided visits to an area vernal pool sometime later this spring. And those dates, of course, will be determined by the weather, the warming pattern in the spring, so that the frogs and salamanders will have already laid their eggs for you to see. So stay tuned for an announcement for those dates. So with that, unless Roger has more to add, I'm happy to turn this over to Kevin.
Awesome. Thank you so much. I'm really excited to be here. Before we start, I would like to do a quick land acknowledgement to acknowledge the ancestral unceded territory of the Abenaki people on which we are organizing and learning today. The Abenaki are the traditional stewards of these lands and continue to care for them. We remember the violence they have endured and continue to endure at the hands of white supremacy. We give thanks for this opportunity to share in this place and protect it. Now, thank you so much to the Library and Conservation Commission for hosting. I don't get to talk a lot about the non-vernal pool aspects of amphibians, because that's where most of my expertise and work lies. So I'm really happy to be partnering with some road crossing people and give more of a full life cycle overview. Because when we're conserving species, we can't only conserve them at the 5% of the time where they're breeding. We have to also conserve them for the 95% of the time they're not breeding. Just a little background on VCE. We're a wildlife nonprofit headquartered right here in Norwich. We're on the Norwich White River Junction line. We're heavily involved in conservation with birds and bugs and vernal pools throughout Vermont and into the Caribbean with our work with migratory birds. To put this talk in context, this is where our vernal pool amphibians are now. Salamanders are buried down in rodent tunnels below the frost line, whereas wood frogs and spring peepers are actually in the frost line. These two frog species are what we call freeze-thaw species, and they pump their cells full of glucose and uric acid to dehydrate them and prevent the water in the cells from bursting and becoming damaged, which is what damages things that get frostbitten. So they are right under the surface, whereas the salamanders go much deeper because they don't have that same tolerance. And that's also why peepers and wood frogs are two of the earlier species you see, because they're so close to the surface, and any rain that comes down and penetrates the ground can kind of activate them and kind of bring them back to reanimation. One other concept I really want to familiarize people with is the idea of a life zone. This is the area that's based on the average migration distance of the different vernal pool amphibians. Of course, salamanders aren't quite as mobile as frogs. They can't hop. They have very small legs. They're not built for speed. And so they don't travel quite as far as wood frogs, which disperse the furthest. Females generally disperse farther than the males. So this is kind of the minimum area that we suggest using as the life zone. But you could expand it out to 250, 300 meters. There's really no limit. It's not going to hurt. It's not going to hurt at all to have a bigger life zone, right? And the real problem that we see, not the real problem, but one major problem on the ground we see is when this life zone is developed or deforested or transected by a road, which is going to be the first thing I talk about, the road, migration. If you evolve to only have to go through a couple 100 feet of hardwood forest, and then suddenly a road gets put in, that's dangerous. That is a lot of extra potential runoff. That's cars hitting you. And it's just more exposure to predation as well. And migration and breeding are really the only times you see these spotted salamanders. The rest of the time they're underground. So it's a really exciting time for 5% of their life when they're above ground. You get to see them and you get to help them across the road where these large concrete barriers essentially have been placed. A quick, not scientific diagram I put together. So this is upland habitat where they are all currently hibernating. You throw a road right here between the upland habitat and the breeding habitat, and that forces them to cross it. Depending on the edge of the road, they might not even be able to cross it. If it's a 2-foot cement edge and you're a little spotted salamander, you may not be able to even get over that. So it could either completely deter migration or, excuse me? Oh, sorry, I think someone was on. Or they risk getting run over by cars. This is especially dangerous in the spring when all these adults are making way and they all haven't bred yet for the year. So if an adult gets hit on this migration, that's a lot of lost breeding output. And where are these? They're all over the state. They're everywhere that there are roads and vernal pools, which is everywhere in Vermont. These are sites or known or potential crossing sites from North Branch. Red means no surveys have been done yet. Yellow means some. Green means lots. I'm going to show an Upper Valley centric slide in a second. So you can see anywhere they focus their mapping efforts, they found a good amount of potential sites, and folks can submit their own sites to get added to this map as well. Unfortunately, death is pretty common at road crossings. I didn't want to dwell on that though, but I do have a quick photo of a dead frog popping up, just in case anyone doesn't want to see that. 3, 2, 1. So when I mentioned the damage that these can have to breeding species or breeding individuals, this is what I really mean. On the left, you have what I assume is a very gravid female that hasn't laid yet. When you see these really, really big frogs in the spring, they're usually filled with eggs. And if one of those gets hit, that's thousands, hundreds, thousands of eggs potentially that can't get laid. Whereas if you hit them in the fall or more toward the summer, they've at least gotten those eggs out for the season, so they can at least have the potential to develop. And when you have a really low survivor rate, every single egg mass counts. This is for wood frogs, but some vernal pool species I'll talk about down the road, like blue spotted salamander, only lay 3 embryo at a time, 3 to 5. So if you have half of those embryos getting knocked out with an insanely low survival rate, that's not going to that's not going to be a successful population. That's going to go extinct locally. So what can you do? You can get out and you can look for them. You can go and you can confirm sites, you can add sites, and you can get out with friends, family, whoever else. I get out by myself just as like a relaxation thing in the spring. I love doing it. And you can go look for these sites. You can help ferry them across the road. You can at least make people aware that they're there, so they might slow down and try swerving to avoid. Although that's not very successful a lot of the time. It's just best to avoid crossing these sites. So I would like to show you one of the sites that I wander in town at Union Village. This is a map off of iNaturalist, which is a great website. I submit every single road crossing amphibian I find on iNaturalist. So that I can go and I can export all these observations at this one crossing. There's a vernal pool right here, and there's a larger body of water right here. And I found almost 100 spotted salamanders in just 3 hours at that site. And mind you, that wasn't during peak time. That was when I'd be going at like 10, 11, but things might not peak at migration until 1 or 2 in the morning. So the numbers are probably even higher. Spring peepers are kind of interesting. They're not really a vernal pool species in the same way we think of other species that have big egg masses. They lay individual eggs, so they're more able to lay in the permanent bodies of water than other species, and I'll explain that in a second as well. On the planning level, on the larger scale, you can integrate road crossings into infrastructure. This on the left is an example from Moncton. Because of people that were out monitoring the crossing sites, they knew there were huge levels of death, in excess of 50% mortality, and that population has some rare amphibians in it, and is a very large wetland. So it would have been devastating to go locally extinct. So I believe that one of these it was a $300,000 project. About 120,000 was donor contributed, and it's huge. It's used by porcupines and bobcats and everything. And you can also go smaller, not quite as big, not as monumental, but still something that can be considered whenever you're putting in a new roadway. And there's a really cool video that some folks got at that Moncton road crossing. I'll play it quickly. Every minute they took a photo for the course of the night, and to just see how many amphibians are crossing in there. Just tons. The way that these work is they funnel all the amphibians toward this one crossing spot by preventing them from crossing elsewhere. I'd like to turn it over to Ben for a couple of minutes. They're going to talk about what's happening on the local Upper Valley side of things for these road crossing conservations.
Thank you, Kevin. And hi, everyone. My name is Ben. I'm with the Hartford Salamander team. We're now actually going by just the Salamander team because we're kind of Upper Valley all-inclusive at this point. But just to briefly go over what we're doing, Kevin is showing the front page of our website, which was a new and kind of improv project. HartfordSalamanderTeam.org. That's our home webpage. You can find out everything that we're doing right there. And that map that is displayed, that is currently zoomed in on, that's a crowdsourced map with currently about 100 amphibian road crossings that originally just Hartford residents were contributing to. And we got about 100 spots in total throughout Hartford, Woodstock, Hanover, Norwich, Heartland, Brownsville. I think Thetford and Fairleigh too, but we're in a lot of towns now. And what that means is we have about 150 volunteers that go out each season, and they go out at spots just like this. As Kevin mentioned, there's a forest on one side and then a wetland or vernal pool on the other. And these frogs and salamanders are, come the start of April, they're actively trying to cross on each rainy night. So team members are just volunteers that are wearing reflective vests and going out in the rain, more or less. And they're scooping up the frogs and the salamanders and helping them across. And there's someone in the audience tonight named Pete Kirby Miller, but he's, and not to put the spotlight on him, but he's from the North Branch, or sorry, they're from the North Branch Nature Center. And the North Branch Nature Center coordinates a big community science project that monitors amphibian mortality across the state and now into New Hampshire as well. So the Hartford Salamander team is part of a much bigger community science project. And next Monday at 7 p.m., we're gonna have a training for any new volunteer that wanted to get involved with being an amphibian crossing guard or with like really any aspect of this project. You don't have to go out in the rain if you don't want to. But yeah, to get a link to that, you can email hartfordsalamanderteam@gmail.com. Or you can go to the website. We'll have a link posted there. And we have a Facebook page too, and an Instagram. And yeah, I recommend the email list. That's the most frequently updated thing. And I think that's the last piece of info I'd like to give you all. And thank you very much, Kevin, for having me.
Great, yeah, thank you. Yeah, this something I totally spaced to mention. If you're not from, like obviously if you're in the Upper Valley area, it'd be great to have you involved with this. But if you're not, forming a local crossing brigade is a great way to help species. Just because you're not near VCE or you're not near North Branch, your data is just as important as anywhere else. And get a couple buddies together, a couple families, some kids, whomever, go out and just start looking at the sites. It's a really fun activity on maybe a Friday or Saturday night if you're on the younger side. But yeah, it's a great thing to kind of have that whole group going.
Speaking to that really quick, the Hartford team started first, but now there's also a Brownsville team that's organizing independently. There's a Heartland team that's also independent. I believe Hanover's making their own team. And they're all volunteer organized, but I think at this point, the conservation commissions are all invested partners and they're all helping with the outreach.
Yeah.
And
so this is great. And I think we originally talked about maybe pausing here for questions, but I think I actually want to maybe keep the good vibes going because we're just on crossings, right? We haven't even gotten to some pools, but I just want to, while people think of their questions for the road crossings, I just want to highlight that there's some good energy in the chat. People have talked about where they're zooming in from Knoxville, Tennessee to Hamden, Connecticut, and then of course all over parts of Vermont. And we also have an impromptu poll about their favorite vernal pool inhabitants. So that's pretty exciting, and we'll just keep asking your questions in the chat or think of them, and we'll carry on. So thanks.
Yeah, Margaret, I see your question in there about clear cutting. I will talk about management in a little bit. One last slide for this section. You know, it's always nice getting some signs out there. Luckily, a lot of our crossings are the one that I look at on Union Village. After 11 o'clock, there's just not many cars going across it. So some sites are a lot more susceptible to these crushes depending on how busy they are and the time of day that they're most used. So these signs could be great depending on the site. You know, just something to put out there. Great, now they've migrated. Where they migrate to? To a pool in the middle of the woods. Vernal pools are kind of the nurseries of the forest for a lot of species. You know, these vernal pool amphibians. There's other species that may utilize them for other parts of their life cycle, which I'll talk more about the importance of it in a second. But first, to define a vernal pool, there's a lot of different definitions for it. And depending who you ask, you might get a different answer. I consider vernal pools to have a seasonal wet-dry cycle and no permanent inlet or outlet. Seasonal wet-dry cycle doesn't mean they have to dry out every year. They may only dry during severe droughts, depending on the bedrock, soils, everything, and the size of the watershed. But they do still fill in the spring and at least lower down in the summer. And then no permanent inlet or outlet, it's kind of a similar thing, where if it's permanent water always flowing in, that's kind of just part of a stream. And both these things help prevent fish from getting established. The seasonal wet dry cycle, if the pool goes dry every year, every other year, every 5 years, any fish that get introduced won't survive. And if there's no permanent inlet or outlet, how would fish get in there? You know, there's always the argument of people sometimes introducing fish, which is obviously never a good thing to do. I've heard people saying, oh yeah, an osprey might drop a fish in the pool. That I don't know that that's gonna happen either. So like these are kind of the two things I go for. Some people might throw in a third requirement, such as it has to be a natural pond. It can't be like a human-made one or an impounded pond. I think that that's a fair assumption, depending on the type of vernal pool you're talking about, but solely in the sense of breeding habitat, I'm kind of going off of this definition. And they are just oases in the woods. They fill up, though, depending on where they are, anywhere between a meter and a half to only 6 inches all the way through. And they're in these low-lying pockets generally, either between hammocks or where there's bedrock that's pretty porous, or where there's a depression from like a glacial boulder or an iceberg, kind of like a pothole. And they dry out, and a lot of the years, some pools look like this in July, and it's pretty disheartening when not all the amphibians had a chance to make it out and metamorph. But that's just part of the trade-off of using these temporary sites that don't have fish in them, no predator, but the trade-off is you have to make sure you're getting hatched and out of the pool really quickly. So why are they important? Obviously, habitat for breeding amphibians and other species, such as fairy shrimp, which are mentioned, caddisfly, a lot of other insects, and then hunting grounds for birds and raccoons. If you have every single salamander in a 3 acre, you know, and of course, just making that up top of my head, but again, an X amount of acre space converging on one site, that's a lot of biomass for predators to take advantage of. They also facilitate amphibian dispersal. So some of these guys that I found on road crossings don't breed in vernal pools. For instance, bullfrogs and green frogs both overwinter for at least 1 year, usually several years, as tadpoles before they become adults. So if they're breeding in a vernal pool that might dry up, that won't work. So they breed in permanent bodies of water where their tadpoles can get down below the ice line and overwinter. But they still need to disperse across the landscape. And these vernal pools act as great stepping stones to get from point A to point B, where they won't breed here, but it's still a wet, oasis in what could be a really dry forest with really dry, crunchy leaves. And if they can only move on rainy nights or when it's wet enough, they can just hang out in the vernal pools until they have an opportunity to move, such as a rainy evening. And then finally, they provide a lot of ecosystem services, flood buffering and runoff mitigation, some other water type things. And then nutrient cycling is huge. When you have a body of water that has algae growing in it, algae is not growing up on land in the air or anything like that. But if you're algae growing in the water and the detritus such as leaves, that's the basis of a very, very extensive ecosystem, where it goes all the way up from the leaves to small inverts, all the way up to birds, mammals, other species. So these provide very, very, very highly active and very productive ecosystems compared to much of the surrounding forest. Now I'm going to focus on the vernal pool species, the vernal pool specialists. I'm going to touch on 7, 4 amphibians and 3 inverts. So this should be an obvious one, wood frog. Everywhere in the state, a lot of people are familiar with them. Spotted salamanders are also probably the most well-known salamander we have, at least the ones that breed in vernal pools. These other 2 salamanders, the Jefferson salamander and the blue spotted salamander, are not statewide. They're much more uncommon. This is called a fingernail clam. They're just little, smaller than your finger. They're clams smaller than your fingernails. It's a pretty self-explanatory name. And then fairy shrimp, which you saw some people mentioning, which are arguably the rarest. No, I guess not arguably. They are the rarest of the vernal pool species that we look for. And there's one other invert I'll talk about in a second. Wood frog I mentioned everywhere in the state, primarily terrestrial, unlike bullfrogs or green frogs. And of course, they're tadpoles, mainly only, they don't overwinter, they metamorph the same season, so that's why they can use these vernal pools. And they're probably the earliest migrants to a lot of these vernal pools, partially because of that freeze-thaw life strategy. They can get up very early when there's still ice on the pond even and start migrating. Their eggs, being the only eggs you really see in vernal pools, are pretty distinctive. You can see each individual egg, each individual embryo individually. There's no outer jelly layer, and I'll compare and contrast in a second. And they also tend to breed in these large egg mass rafts. And if you can, it's hard to see, but this photo, the surface is actually refrozen over, which is another reason why these individuals really like to get there as early as possible. If you are the first wood frog there and you get your egg mass right in the middle and everyone builds off yours is more protected from the edges. And if the water is to refreeze, the eggs on the top surface may not survive. But if yours are below there and being warmed by other surrounding eggs, you have a much better chance of surviving, or of your eggs surviving. So there's a real evolutionary benefit to getting there as soon as possible after the water starts to thaw out. This is a piece of data from our vernal pool project. It's the date that wood frogs start calling. Of course, this year, or I guess this past year, 2021, was a very dry year and a very early spring. So a lot of the pools had earlier call dates. I don't know how much earlier it can actually get. So I'm predicting that this season will be much later than 2021. I've already talked to some monitors and they're like, yeah, we still have 3 times more snow than we had last year. So I'm really excited to see, after they've been progressively calling earlier, how they'll kind of rebound, and if it will rebound even. Spotted salamander is definitely the most well-known and most charismatic. They're really long-lived, up to 20 years, and they're big, up to 9 inches. So in that 20 years, they can just keep growing. And as I mentioned earlier, if you have a big female individual, has a lot of potential to reproduce, and it gets killed in the off season, especially if it's gravid with eggs, it's a huge loss, especially for these long-lived species. They are a little bit later migrants. They don't migrate as early as the wood frogs do. They wait for warmer spring rains and less less ice on the ground. But you'll still see them moving in the first couple weeks probably of migration. On the left, so these are both spotted salamander egg masses as well. They have very variable colors. On the left of this white one, it's genetic. There's some spotted salamanders that genetically only lay white milky eggs. There are some that only genetically lay the stereotypical clear eggs. And there's been a lot of really interesting research about how like the ratio of clear to opaque like differs between different elevations and different situations. So it's a pretty interesting area of study. On the right, it's a clear egg mass, but it's green. That is actually a symbiotic algae called Euphila, which is found in specifically spotted salamander egg masses that turn them green. There's no negative that we know of. It's a good thing. It just helps kind of keep the embryos healthy. But it's pretty interesting that they have a symbiotic algae that lives only in the egg mass. I think that's really, really neat. And a quick comparison of wood frog, or I guess frog in general, to spotted salamander or the other two salamanders we'll touch on. This spotted salamander egg mass has a kind of a milky white, opaque outer jelly matrix, this outer embryo of jelly, compared to wood frog, which doesn't. It's thought to act as a protective layer between like newts and the egg mass, though newts just eat right through it, but also like holds moisture better. There's a couple different thoughts of why they have it. So it's a pretty distinctive difference between frog, no outer layer, and spotted or salamander in general with the outer layer. One other thing to look at is this white halo around the black embryo. You can see pretty clearly here, it's wide. That's called the vitelline membrane. And in frogs, it's not visible. So if you're looking at an image, doesn't have to be a great quality image, you can usually see, is there this white halo or not? If there is the white halo, it's a salamander egg. If there isn't, it's a frog egg. I'm sure there are probably exceptions to that rule, but like in the terms of vernal pool species, at least. Jefferson salamander is another one of the vernal pool salamanders, slightly smaller than the spotted, between 5 and 7 inches maybe. As you see, it's sporadically distributed across the state, whereas the spotted salamanders everywhere. There's a couple pockets that have the Jefferson salamander complex, which I'll again touch on in a second. That does include Norwich. We do have some sites that have spotted salamander egg masses in Norwich and the surrounding towns, of course. I know on Giles, I've seen a couple on some different pools, near the Union Village area. So they're really neat. They have smaller egg masses than the spotted salamanders. And if you look at that vitelline membrane, that white halo, it's much smaller with Jefferson than it is with spotted. With spotted, it's like the same width as the embryo. Or sorry, with spotted, it's like the same width as the embryo, but with Jefferson, it's much smaller. And then the final vernal pool amphibian that I'll talk about kind of is the blue spotted salamander, which is pretty much found in the lowlands of the Champlain Valley and some scattered sites elsewhere. These are the smallest of the vernal pool salamanders, between 3.5 to 5 inches. And we don't really have them here in Norwich, but we do have the blue spotted Jefferson complex, which is why I said they're kind of going to have a 5th amphibian, but not really. These are hybrids, but not hybrids in the traditional sense. It's not like there aren't populations of Jeffersons that are actively hybridizing with blue spotteds. Basically, like hundreds of thousands, millions of years ago, there was a hybridization event, and the offspring from that event were all female, they were unisex, and they were triploid, or they had more or less chromosomes, or I guess pairs of chromosomes in some of their cells. And so now these all female populations can accept reproductive like DNA from either male blue spotted or male Jefferson. Then the female can, it's called then the female can kind of like pick and choose almost like what DNA gets used. It's not like it's not a 50-50 split between the father's and the mother's DNA. The female does something called kleptogenesis. It's the only species or only vertebrate known to do this, where they, like I said, kind of pick and choose and almost like steal, hence the klepto and kleptogenesis, what DNA goes into their offspring. There are a ton of these in the area. I think that we have a pretty high, like I'd say that most of the, not most, but a lot of the egg masses I've seen on Giles have been these hybrids. You can usually tell because they have more white infertile embryo than most egg masses do. But there's really no way to tell 100% unless you do DNA tests, which is not something I'm willing to take on at the moment. So there's definitely more study to be done, but it's incredible life history. It's the only vertebrate we know that this has ever occurred in, and now we have these all female populations that have kind of dotted the Northeast. Fairy shrimp, I saw a couple people saying this is their favorite vernal pool species, and I won't deny it's definitely, I think, mine. Maybe tied with blue spotted salamanders, but it's very rare in vernal pools. Less than 5% of mapped pools. This map here is basically what we currently know to be the distribution in the state. So we don't know a lot. There's a lot of sites that haven't been visited in 10 years that, in 2012, they had fairy shrimp, but it hadn't been visited in 10 years. Who knows if they still do. They really prefer clean woodland sites. They're not something you'll frequently see in, like a ditch on the side of the road. I don't know if you would ever see them there. They really do need that clear, clean water. And their entire life cycle is based in vernal pools. They lay, not eggs, they lay cysts, which have like already developed embryo in them or already developed young in an early stage. And then they have to go through a freeze and thaw cycle. Different species have to go through different temperature cycles to activate those cysts. And then when the pool finally refills, those cysts hatch. And then they're only around for a couple months at most. They thrive early in the season because there's no predators, to predate them. But once, especially salamander tadpoles get larger, or water bugs start to show up in the pool, they get eaten pretty quickly. They don't have any natural defenses. They're pretty gentle creatures. So they do have a bloom cycle, and then they bust, and then they're pretty much all gone by June, maybe even May, depending on the sites. Here's a great video from Pomfret of a massive fairy shrimp bloom from last year that I really want to play. See, just so many of them, they're so cool. They school up almost like sardines. They're just the neatest little creatures. And their temporary life cycle is just so neat to me that they're only alive for 3 months, but they may have, how many X number of generations have lived in the same sites. Did I just lose the presentation, or is it still up?
We still see you.
All right, yeah. Cool. Sorry, I thought I exited out of the screen. Cool. And then don't want to play it again. Fingernail clams are another species I mentioned earlier, present in like 1/5 of mapped pools. They bury down into the litter, leaf litter, or in the substrate muck, especially when the pool's dry. So these are really, really useful if you're trying to identify a potential vernal pool site when there's no water there. You can rummage through the leaf litter and look for them. And if you find them, it's a very good chance that there is at least some type of ephemeral body of water there. There's one species that is a vernal pool specialist that's only found in pools that dry up annually, called the Harrington's fingernail clam. I don't feel comfortable IDing them down to species. That's on my bucket list to get to eventually, I think. But these are a great tool, especially in the summer or fall when there's not water in the pool. One other macro invert I want to touch on that isn't a vernal pool specialist, but we still look for them in vernal pools is the caddisfly. They look kind of like moths, but they have these really, really interesting larvae that build these elaborate cases around their body, which act both as protection and as camouflage. It's also really interesting that they that case increases the oxygen flow in still water environments. If you have a little, just a little pulse of water that hits this case, it's going to deflect off in all different ways. So it's another strategy of trying to get all you need in to survive in these kind of resource poor environments early in the season. One other really interesting thing about these is people can actually use them for jewelry. You can put a larvae in with like gold leaf or anything like that, and you can then take that case and build a necklace or earrings out of it. It's a pretty niche jewelers market, but I could see that being pretty cool. And the final two species, or I guess groups I'm going to mention, one is the spotted turtle, which is probably the most highly susceptible vertebrate in Vermont to poaching. A very active trade in the pet trade for these guys. So their locations are guarded very, very secretly. They're only found in 3 different counties. I don't know where they are any more than what counties they're found in. They forage near vernal pools and in vernal pools when they're in like a larger wetland complex, and they'll move over a mile across the land to find them because there's easy meals, lots of eggs, and there's no predators, so they don't have to worry about like a gar or something coming up to chomp on them. And they're small, 3 to 5 inches. I just think that they're such a neat creature. We don't really think of poaching as a lot of, you don't really think of poaching as a big issue in Vermont. But for some of these reptiles, especially the turtles, it really is. And then owls and hawks and kingfishers and blackbirds and a lot of other species will have been seen either hunting in the pool or hunting on the edge of the pool and snagging up any larvae that may be leaving the pool or that are just close to the edge. So quite a smorgasbord for a lot of these species. Cool. I have another quick break in there, mostly for me to get a drink of water, and then I'll go through the chat real quick. We won't be able to sleep tonight if we don't hear more about peepers being vernal pool inhabitants. I mean, they're definitely found in vernal pools, but because they lay their eggs singly and not in these big masses, they can hide them much easier. So they can go to these larger bodies of water that may have fish in them and lay their eggs on the underside of vegetation, underside of logs and other things. So they're still hidden away and not as susceptible to breeding as if there was just a big floating mass of jelly that that doesn't take teeth to eat or anything. So it's not as much that they're not in vernal pools, it's that I don't consider them a vernal pool specialist, and it's just so hard to find their eggs that it's like not even worth surveying for, which is why I don't necessarily include those as the vernal pool species were mostly of interest.
So one of the other questions, Kevin, was what are some vernal pool inhabitants that might not be seen with the naked eye? Are there any? And if so, what are the coolest? And then does VCE, the Vermont Center for Eco Studies, do any work in microscopes or other technical work in seeing these non-naked eye inhabitants?
There definitely are, like Daphnia, pretty popular. There's like ghost midges. Like they're definitely, there's a huge assemblage of species. We mostly focus on the macro invertebrates, so meaning that you can see them with your naked eye. And I'm not an invertebrate guy, so it's definitely not my expertise. But I totally see another project or building a part of that into this project of like sampling water and bringing them into the lab to look at under the microscope. It's small steps when we're trying to build this out, but that's a great point. There's a lot of species that are found in vernal pools that I'm not touching on. If you go back to this, you know, you have, depending on the pool, you have isopods and amphipods, you have snails and worms, and you have the parasites and stuff. It's incredibly diverse.
What
For better for worse, we like focusing on the larger species we can see, though.
Cool. Another question is, what is a seep, and what's the difference between a seep and a vernal pool?
So a seep is not, there's not necessarily like a body of water at a seep. It's just a wet area where water comes out of. So they can form vernal pools or supply water to a vernal pool. But it kind of again comes back to the question of what is a vernal pool. Some people may not consider that to be a vernal pool if it's seep fed, because that's a permanent inlet of water to some extent. It's not a stream, but it's basically like groundwater coming into the site. So I see for vernal pools, it's kind of like a gray area, but there are salamanders that use seeps, like dusky salamanders use seeps, two-lined and four-toed use seeps. So it's just a slightly different environment, but they can definitely kind of go together.
Okay, cool. And there was a question about the conservation of vernal pools, but I imagine you're probably going to get to that next. So maybe we can go for another 10 minutes or so and then take another round of questions. Does that work?
Yeah, that works. And yeah, I'm right on it. I like the way you're thinking. Yeah, conservation and management. When I'm talking about, or when anyone's talking about these amphibians, 99% of the time they're talking about when they're migrating or when they're breeding. That's only 5% of their entire life cycle. Sorry, I was reading a chat. Yeah, so 95% of the time when they're not breeding, they're near the pool, but underground. Frogs may be hopping around. And because of the temporary nature of vernal pools, they're really easy to degrade. They're really susceptible to degradation because they're really easy to come across when they're dry and you may not know they're there. There's plausible deniability if you pretend you don't know there's water there and then you just happen to go and find it when it's dry. And they're hard to map. If the environment's only present for 3-4 months out of the year, it's a fast and furious 3 or 4 months to get people out there on the ground and mapped. So historically, I think that vernal pools have been like neglected ecosystems because a lot of those reasons. I'm running low on time, so I'm just going to touch on these two headers here. The two goals you have when you are managing for a vernal pool with vernal pool conservation in mind is you want to maintain the vernal pool depression in its current state. You don't want to put heavy machinery in the vernal pool depression. You don't want to remove any slash. You don't want to harvest trees that are in the depression. You really want to try and leave that alone as much as possible. And then you also need to provide quality non-breeding habitat for the entire population, which includes maintaining a closed canopy, keeping bare soil to a minimum so that there's not a lot of extra runoff. And then a huge one is harvesting only on frozen grounds, because that prevents skitters from causing massive ruts that could become population sinks or even barriers to migration. I'll add another thing that regarding forestry and vernal pools, there are no regulations about forestry around vernal pools. You can, in theory, clear cut anywhere around a vernal pool and you're fine. The legality or the issues with legality come in if you're dredging the vernal pool or really really changing the basin. But forestry wise, there's not any regulation. That being said, especially in Vermont, where we have such an incredible conservation community, foresters are always happy to try and maximize the habitat for these species. If you do need to go and do a harvest, we suggest that within 100-foot buffer, you maintain 75% canopy closure. And in the rest of that life zone, that 400 to 600 plus feet, keep it at around 55% canopy cover. The canopy is really important for these species because it maintains the moisture on the ground. less direct sunlight means more moisture, which these species need to disperse and move around the landscape. It regulates the temperature by having more shade, and it provides down woody debris, which when you're looking for salamanders, that's what you turn over to find them. If you have a lot of trees still up there, that's gonna be more branches and stuff falling on the ground. And again, nothing being done in the basin. You don't want to touch the basin. You don't want to risk messing up the hydro period or anything like that. Some management resources, Maine Audubon has a fantastic guide. VCE has a handout, which is where this came from. And just, county foresters. County foresters are more than happy to come out, check out your landscape, talk about your management options and your conservation goals as a landowner. So I definitely would suggest, if you're going to be planning some management around a vernal pool, even if you have a private forester, maybe get a second opinion from the county forester or someone else that you trust. I have 2 more slides. Vernal Pool Atlas, this is one that VCE runs along with Vermont Fish and Wildlife. It's a atlas of all the vernal pools that we know of in the state, which feeds, or I guess will feed directly into the Vermont A&R Atlas. Each of these orange dots is a potential site, and any of these blue triangles are confirmed pools. There's a lot of confirmed pools in the Norwich area. So if you're ever interested in getting out and looking for pools, you can come check out this site. Or if you visit a pool, you can fill out a data form and submit it to the site and actually log a visit to the vernal pool. And vernal pools are only visited once every 10 years. A pool could be developed at year 6 and we won't know for another 4 years. So getting regular visits done to vernal pools is very helpful. Vernal pool monitoring, that's one of my big projects. We just have a bunch of sites across the landscape that we track egg masses at, and some other amphibian life history parts. I really ended that on a bang, right? Thank you so much for listening to me ramble on. As Sherry mentioned at the beginning, we will be doing a vernal pool walk sometime this spring. Date TBD, so keep an eye out on that. And I appreciate everyone for tuning in. I hope that you learned something new and you found something interesting and maybe motivated you to get out for a night this spring and give it a try. And I'm happy to field any questions or comments that people might have as well.
Oh yeah, the folks heard that you're ending, and so they're asking good questions. So so let's see. So someone asks, what about hiking and bike trails near pools? Is there an ideal distance hiking trails should be from vernal pools?
I wouldn't say there's an ideal distance, and it definitely depends on how heavily trafficked they are. If it was the Appalachian Trail, that'd probably be causing a lot of runoff from excess soil. But if it's not a heavily used trail, I don't think it plays that big of a risk. It's really the exposed soil that is an issue. So if you build the trail really well with a good foundation, like I did when I was with Green Mountain Club, or I know a lot of the local land groups do, that definitely mitigates the runoff. And as a whole, like a trail compared to a 2-lane plus driveway or road, yeah, it's going to not really play much of a role in the migration itself. The real issue would be the runoff, but I don't think that'd have a huge impact.
Someone, that's great. Someone asks, I appreciate this question. Is there a minimum size for a puddle or a body of water in the woods to be considered a vernal pool? Like, what's the threshold for vernal pool status, I guess?
Depends who you talk to again. I would say that as long as the pool provides breeding habitat for one of the breeding amphibians, it's a vernal pool. Like when we get down to the legal sense, there's more nuance, such as if it's an isolated vernal pool or if it's part of a large wetland landscape. But in my eyes, if it has breeding, those four amphibians, those vernal pool salamanders, if it has any of those breeding species, it gets called a vernal pool. I guess it's 1 frog and 3 salamanders rather. So if they're present, I say call it one. And then max size, people can say there's a maximum size. Some people say it's 1.5 acres. Some say like half a hectare is kind of like how big most of them get. but like that's, again, I don't really know how exciting or how golden of a rule that is about if a pool can get too big and at what point it becomes a beaver meadow and not a vernal pool or whatever.
Right. And so this question gets to sort of the ephemeral nature of vernal pools. So when you map a pool, how do you mark it and its land area perimeter so you can then find it after it's dried out? Do you want to find it after it's dried out? I guess I would editorialize.
So we get lat and long coordinates at the pool. That's what we mostly use. There's been some really exciting work done with remote sensing and using LiDAR data, which has the, it's like a layer that shows the topography of the landscape, not with houses or anything, just like the bare soil topography. And you can take that and simulate, like kind of like simulates liquid almost, and it finds where there are sinks, where the water's gathering. And then using different techniques, you can delineate what the edge is, and then you can go out and field confirm, and using the field confirming and how accurate your trial was, you can refine your model. That's been a big thing down, or I guess over in Michigan. They've been doing a lot of work with that. I think TNC is going to be doing some work with that this year. So I think that as remote sensing gets more and more popular, it's going to become more and more of a remote sensing thing. The easy thing would just be to do a lap around the pool and track that, but you know, who knows how useful that is. So I'd say LiDAR would be the best way.
Cool. What are some of the top risks to vernal pools from climate change?
Probably change in precipitation. A lot of pools get filled from melting snow. So if we have smaller snowpacks, that's going to be smaller, or I guess smaller snowpacks is less water to fill these pools. And if that goes along with climate change and warmer springs, they might evaporate quicker. So less water going into the pool. That's not even talking about potential changes to rain, and warmer springs, drier summers doesn't really bode well if there's not enough time. They need the 8+ weeks, depending on the species, to actually breed and metamorph. So it could have some really bad consequences on local populations, depending on how extreme it is. And we really don't know how extreme it's going to be.
So are there other things other than snow melt that feeds a vernal pool annually?
It's mostly just snow melt and rainfall, like the melting frost layer in the soil also supplies water, but it really is just the runoff, which is kind of the marvelous thing about them, is it takes a lot of water, and it takes some really, really specific circumstances to have a natural basin that the water can form and not leak out of in a matter of days, and to also be shaded enough and have enough cover to not have it all evaporate out right away.
Okay, so that's great. And some folks have been recommending some reading material in the chat. Is there, does VCE or another place sort of collect reading material recommendations, or, the library may, I should know this, but I'll check with you first. Or do you have a good vernal pool book that is sort of the vernal pool go-to?
Me?
Yes.
Yes. I do have a couple. I have my own natural history library, actually. So a couple of the books that I think are great. One, just like the field guide to reptiles and amphibians in New York. There isn't a Vermont centric one, but this covers all of our amphibians and herps and additional ones from New York. These are both more of like technical manuals, so kind of more of like a textbook than a field guide. But if you're going to be referencing a lot of literature, or looking up some basic questions like what species are found where, or like how's the hydrology differ, what is a vernal pool, those would be really good sources for that. I don't know, I don't have it, but there's a guide to vernal pools that Massachusetts put out that I think is available for free online, and that covers a lot more of the macro invertebrates, like bugs that get laid later in the season, and other species like the question about what other, non-visible inverts live in pools. It covers a lot more of that. Oh, yep, Pete just put it in the chat. Ben, the author is Gibbs et al.
Okay, so Kevin, we could probably talk after this, and we could maybe figure out some resources that we could follow up with folks, because as a library, we're of course happy to share resources, right? So I think this might be a good place to stop. If you could maybe stop sharing your screen, just so you can see everyone potentially.
Oh, yeah.
I'm gonna not spotlight you and I, and maybe folks might, wave to you, and because you've been getting some good praise in the chat all evening. So
it was a lot of fun. It's always nice to be able to mix it up and talk about something else that I still really care about, and I do more as a hobby than as part of my job. Like, I don't really do anything with road crossing as part of my position at VCE. It's all a hobby, so it's always fun to be able to talk about things I really enjoy doing outside of the economics of it, and be able to hopefully get other people out there as well.
Okay. That's great. And so thank you to the Hartford Salamander team. Thank you to the Sherry Asa and the Conservation Commission. And I should say, please check the Norwich Library website frequently. We have some good stuff coming up. We have a Smithsonian curator visiting us in May, and we have a talk called The Promise of Access that deals with technology and how it looks to solve problems of poverty in April. So good informative topics that we're looking forward to. And of course, we'll look forward to our work with the Conservation Commission for future talks. Sherry, is there anything else?
Yeah, I'd like to just remind people that Kevin will be leading a guided tour to an area, Vernal Pool, later this spring, as soon as it gets warm enough and there are some egg masses in pools. So stay tuned for that. We'll put announcements in the Norwich list and probably other places around town.
That's great. So I think I thanked everyone. Thank you, of course, to our partner, the Vermont Center for Eco Studies, and Kevin. And yeah, thank you, everyone. All right.
Yeah, thanks.
Thank you.
Bye, everyone.